I'm Beshah Ayalew. I'm a professor of automotive engineering at Clemson. In VIPR, I'm a PI for one project. The title is Energy Management of Multi-Scale Vehicle Fleets. As the title suggests, basically it deals with developing algorithms for efficiently using energy for a fleet of vehicles, which could be unmanned ground vehicles, aerial vehicles, different sizes and shapes.
My name is Zhang. I'm an associate professor at the Department of Automotive Engineering in Clemson University. For this VIPR-GS 2.5 project, we designed the mobile microgrid. So for a mobile microgrid, it has a military application, for instance, for emergency operation, or you supply temporary power for the military base. Then for the mobile microgrid, we design renewable energy, design battery storage, along with diesel generator. In this behind me, in this operated microgrid emulator, we use 3 amplifiers to represent each of these PV, battery storage, and the diesel generator, so that we can supply to the charging power from UAVs, UGVs.
So our goal is to create algorithms for efficiently managing a fleet of vehicles. So the specific scenarios we're looking at are we have a group of unmanned ground vehicles operating in off-road terrains, where terrains are very difficult, and so we come up with algorithms that are accommodate the terrain, vehicle-terrain interaction, and also other information about the environment that's obtained by either onboard sensors or using UAVs, and then in a bit of modeling, incorporate that model into the algorithms, and so to determine the energy optimal paths, motions for these vehicles, and integrate that with actually a mobile energy source, which is in a form of a microgrid that is hosted on one of the unmanned ground vehicles, which is an automated vehicle itself.
With this kind of design project, the Army, they can apply what we proposed, like the sizing of the diesel generators, PVs, wind turbines, energy storage. They can use our recommended values to quickly form a mobile microgrid. Because within the mobile microgrid, we consider not only the size, we also need to consider the dimension of all of these components, because everything needs to be put inside a container so that they can be pulled everywhere or whenever they need, wherever they need. So that's the mobile part. So from this sense, it's important for the mobile application for both, indeed for both Army and also domestic application, particularly in disaster rescue.
Our work has many layers. So we deal with, like, we call the charge scheduling layer. We're given a mission, we schedule the motion of the host vehicle, the charger, and the individual vehicles are charged from it, while working towards fulfilling the mission objectives. This scenario I described for these vehicles, for example, is very difficult an engineering challenge. So it's a great opportunity for myself, for a faculty team, and especially for graduate students to work on these very difficult problems, to potentially come up with solutions that might be used by the Army down the road. So it's a great opportunity.